Welcome students to the fourth session of the chapter Matter in Our Surroundings. In the third session, we had a discussion on the three states of matter, namely solid, liquid and gaseous, where we focused on the properties like shape, volume, compressibility, rigidity and if it fills the container completely or not. Also, two important terms were shared with you, the kinetic energy and density. Now, if we think deeply about the three states of matter, we understand that there are only three properties of matter which decide whether a given substance will exist as a solid, a liquid, or a gas. These properties are: first, the space between the particles; second, force of attraction between the particles; and third, the amount of movement of particles, or what we say kinetic energy of the particles. If this is so, can we make a change in these properties and can we change the state of the matter? Let us discuss this topic today. Can matter change its state? And the answer is definitely yes. We can change the space between the particles. We can change the force of attraction between the particles. We can change the amount of kinetic energy that the particles are having. And there are two ways to change these states of matter. First is by changing the temperature of that particular substance. Second, by changing the pressure. For example, under normal pressure, water exists as a solid in the form of ice at temperature of 0 degrees Celsius. It exists as a liquid water at room temperature, as you know, and as a gas in the form of steam at a temperature of about 100 degrees Celsius. So let us find out more about what is the effect of change of temperature. Before we proceed further, let us understand the common unit of temperature and the SI unit of temperature. The common unit for measuring temperature is degree Celsius, written as I have written here. It is used in this particular unit is used in laboratories while performing science experiments. Even the clinical thermometer, which we use to measure body temperature, is in degree Celsius. Now, when you talk about SI unit, the International Standard Unit, it is Kelvin. And scientists mainly use it for research work. Advantage of this Kelvin scale is that all the temperatures on the scale are positive. For example, let us try to understand the relationship between degree Celsius and Kelvin. So 0 degrees Celsius, when we want to say, it is actually 273 Kelvin. So when I want to find out what is the measure in Kelvin for 100 degrees Celsius, what will I do? Yes, I will just add 273 to degree Celsius value, and what I get here is 100 plus 273, and that is 373 Kelvin. Suppose I want to know what is the Kelvin temperature in Kelvin for 25 degrees Celsius. What will I do? 25 plus 273, and that makes it 298 Kelvin. Likewise, if you are given temperature in Kelvin and you need to find out degree Celsius value, what will you do? 298 Kelvin. So 298 minus 273, if you do, you will get 25 degrees Celsius. Okay, so this way you can work out, you can find out the temperature in both the scales. Okay, so now coming back to our topic of whether we can change the state of matter, and the first thing we are observed is that we can definitely change the state of matter with the help of temperature, because it is our observation that water can exist in 3 different states at different temperatures, right? The temperature of solid ice. How can we increase the temperature? Yes, by heating, right? So now if I heat ice, it will start converting into water, which is a liquid state. So when we supply heat to solid, it is getting converted into a liquid. This process is what is called as melting, and another name for it is fusion. Understood? Solid getting converted to liquid on application of heat. That process is known as melting or fusion. Now when we talk about melting, at what temperature it should take place? Is there any fixed temperature, or at any temperature melting will start? No. So it is a fixed temperature. The temperature at which a solid substance melts and changes into liquid at atmospheric pressure, the normal pressure is actually called as is called the melting point of the substance. So now, what is the melting point of ice that you know? Yes, it is 0 degrees Celsius. So once 0 degrees Celsius is reached, it will start converting into water. Liquids have same melting points? No, there can be differences. For example, melting point of wax is 63 degrees Celsius, whereas the melting point of iron is 1535 degrees Celsius. So vast difference. So now the temperature at which the solid is going to change into liquid form is different for different substances. So you can say why it is different, because the melting point of a solid is a measure of force of attraction between its particles. So higher the melting point of a solid substance, greater will be the force of attraction between the particles. Now you have seen that melting point of iron metal is so high. What does it indicate? It indicates that the force of attraction between the particles of iron are very strong. Right. Let us move on to the next part. What is the next part? Water is formed. Now, if we still continue heating, after some temperature, you will observe that water gets converted into water vapor, which is a gaseous state. Now this process where a liquid gets converted into vapor is what is called as boiling, or also known as the process of vaporization. Now can boiling take place at any temperature? No. There is again the specific temperature at which boiling of liquid will take place, and definitely it will vary with liquids. For example, water will start boiling, means water will start getting converted into vapor, that is a gas, at 100 degrees Celsius. Whereas some alcohols, they boil at 78 degrees Celsius only. So there is a difference, right? Mercury, which we have it in thermometers, it boils at 357 degrees Celsius. So there is a vast difference between the boiling points. Now again, what does this boiling point of a particular liquid indicate? Yes, it is a measure of force of attraction between its particles. So again, higher the boiling point of a liquid, greater will be the force of attraction between its particles. Now, mercury has very high boiling point, 357 degrees Celsius. What does it indicate? Again, it tells that the force of attraction between the particles of mercury is very, very strong. Right? So, we have understood now that Solid can be converted to liquid on heating. Also, liquid can be converted into gas on heating. Now, just ask yourself a question. Can we revert back from gas to liquid? Can we revert back from liquid to solid? Definitely yes. So, when for liquid we heat it to go to gas, now reverse way we have to proceed. If we are able to cool the gas, we will surely get back the liquid. Now, this process of changing a gas or a vapor to a liquid by cooling is what is called as condensation. This is called as condensation. Now, again, liquid to solid. Can liquid be changed back to solid? Yes. What do? We keep the water in freezer. Means what? We cool it. Likewise, this process of changing a liquid into solid by cooling is called as freezing. Freezing also means solidification. So can we just draw a chart to indicate how we can change from one state to another? Yes, we will make a chart, and in that we can write with proper arrows that from solid state to move to liquid state we need to heat it. This process is known as melting. From liquid to gaseous state, again we heat it. This process is known as boiling or vaporization. Now, to come back from gaseous state to liquid state, we cool, and this process is called as condensation. From liquid back to solid, again we need to cool the liquid, and this is freezing or also known as solidification. So you have understood the terms during the conversion of one state to another. Also, you have understood whether we need to increase the temperature or we need to decrease the temperature when we have to change the state. Now, let us go into detail for this. Like when we started heating ice, what actually happened to the particles? Or any solid, when we start heating in general, what happens to the energy of the particles? Yes, now as soon as we heat up, the particles, they start vibrating vigorously. And due to this, the kinetic energy, increases tremendously. Lot of kinetic energy is there in the particles. And this increased kinetic energy is actually shown as rise in the temperature in the thermometer. Getting it? So, what is the thermometer indicating? The thermometer, when we heat any substance, the rise in the temperature is due to the increase in the kinetic energy of the particles. Why does the kinetic energy of the particle increase? It increases because it starts moving with tremendous speed, and that is why it starts moving vigorously, and so the kinetic energy increases. Likewise, you can go for liquids, you can go for liquids heating to gas. And when we cool, what happens? When we cool, the temperature decreases. Why does the temperature decrease? Because now the particles of gas, suppose we are cooling gas to form liquid, in that case the particles of gas, they will come closer or they will not vibrate as they were doing earlier for gas. So their kinetic energy reduces, their movement reduces, therefore their kinetic energy also reduces. Similarly, when we cool a liquid so as to form a solid, the particles again start reducing their movement, and that's how kinetic energy is reduced. Once the kinetic energy is reduced, the particles will start coming closer because there is force of attraction between the particles, right? So you know how solid looks. If you draw the particles, it is compact, right? So the particles can come closer because they are vibrating less now. They are in their own positions only. So this is the way, this is how a kinetic energy can be increased or decreased by heating or cooling, and accordingly we can then come to the or change the state of matter. Let us now try to understand two important concepts. One is latent heat of fusion and another latent heat of vaporization. Now, latent heat of fusion, this can be understood when we are changing solid to liquid. Let us experiment. If we have a container having ice cubes and we dip thermometer in it and we start heating. Now, even when we heat it, you will not find that there is change in the temperature in the thermometer. Now the question is, we are heating, but why the thermometer is not showing a rise in the temperature? Now how can we answer this particular observation? Now here, when it is 0 degrees Celsius, you will also observe that some of the ice, it is in the process of melting, right? Melting means ice is getting converted into water, but all the ice is not melted to water. There is some ice still in the beaker which is getting converted, and you can say the thermometer is waiting for that ice also to melt. Only when whole of the ice in the beaker gets melted to water, the thermometer will show the rise, otherwise it will stop at 0 degrees Celsius. Okay. Now, why this happens? This happens because originally the ice is suppose at 0 degrees Celsius and we start heating, then this heat which we are supplying is not used to increase the kinetic energy of the particles, right? If there is no utilization of energy for kinetic energy of particles or to increase the kinetic energy, the thermometer is not going to show the rise. So where is this heat going? This heat is being utilized to break the bonds between the particles, and likewise and to overcome these forces of attraction. So there is no rise in the kinetic energy, only overcoming the forces of attraction. And who is doing this? The supplied heat. Correct. The supplied heat is only overcoming, is used only to overcome the force of attraction and not to increase the kinetic energy of the particles, right? Now this process will continue. It will maintain the thermometer will maintain the temperature at 0 degrees Celsius till whole of the ice gets liquefied. Now once you have water in the beaker, again you are continuing heating, so you will observe that now the thermometer will show rise. It will become 10 degrees, gradually 20, 30, 40. Likewise, it will go on increasing the temperature. Now, why thermometer is showing rise here? Yes, because it is increasing the kinetic energy of particles of water. Now, will it go on showing increase? No. Again, it will go and stop at 100 degrees Celsius. It will stop at 100 degrees Celsius. Now what will start at 100 degrees Celsius? The process of boiling. That is process of vaporization. You will start observing the vapors of the gas. Now the whole of the water is not converted into vapor, right? So it will wait. The thermometer will wait and show 100 degrees Celsius till whole water is converted into vapor. So now during this journey of ice getting converted to water, water getting converted to water vapor, we have observed we are continuously supplying the heat. But in spite of supplying heat, the thermometer stops 2 times. How many times? 2 times. First at 0 degrees Celsius, second at 100 degrees Celsius. Got it? Now why this is so? The answer is the heat that is supplied is utilized for overcoming the forces of attraction. We define